Hi, everyone. Thank you so much for joining us today. We're really excited to have you all. We have a few different platforms that this is streaming on. If you have any questions as we go through today's webinar, please feel free to drop them in the comments, and we'll be happy to answer any questions that you have. Today, we're excited to have you for our webinar on centralized multi-cluster management and operations. We are so excited to have both Neil and Siam with us today. We had the pleasure of seeing Neil in person last week at KubeCon, so really excited to have him back on the webinar. So just a quick introduction to our amazing speakers. Neil has more than 20 years of experience in advanced technology, including virtualization, storage, and containerization. As the CEO of Portainer, Neil is on a mission to make the operational management of container platforms a breeze. And then we have Siam. Siam is the field CTO at Civo and has done a lot of work within the CNCF community. He recently gave quite a few talks at KubeCon and is the founder of Cube Simplify. So without further ado, I will go ahead and kick things off to Siam. I'll let you take it from here.
Yeah, if you can just add my slides.
Absolutely.
Yeah, okay. Interesting. Let me switch it to a different one. I don't know. Safari sometimes doesn't like presenting the slides.
Technology, man. Technology.
So let me share now the Chrome tab. Hopefully this should work.
I don't know how you can work in that purple light. It would hurt my eyes.
All right. So yeah, like Neil is the expert in the multi-cluster management side of things, and also the operations with Portainer. I will touch on some of the basics of where we are with the multi-cluster things, especially touching on the Kubernetes SIG as well. We have a Kubernetes multi-cluster SIG. What enhancements have been there since the past, some of the projects, and hopefully we'll be able to do a small live demo if everything goes fine. So Kubernetes cluster. So when you think of Kubernetes cluster, it's a bunch of nodes, and this is the single Kubernetes cluster. So you have a single control plane, and you have a bunch of workers attached to it. You have a scheduler that can schedule the workloads within the same cluster. You have the API server that can take requests within the Kubernetes cluster, and then you have the worker nodes that run your workloads. Interestingly, you can think of it as an isolated space, the complete cluster itself, that has its own set of resources, own set of management system, own set of working parameters which are there. And similar to that, there can be multiple clusters, but they are all isolated and they cannot by default communicate to each other in any way, because Kubernetes is kind of built like that. So when you are in a single cluster and you delete the cluster, obviously all the resources gets destroyed. Everything is gone. All the metadata is gone. All the load balancers that you have created, any Kubernetes object that you have created, it goes away. And there are a lot of reasons why you would want multi-cluster. So let's go through it. So, and there are some of the solutions as well. And there are still problems that exist in the multi-cluster, because multi-cluster is like, yes, there are tools, yes, they solve problems, but it's still hard. It's not that easy. Hopefully Neil can make a few of the things easier. So why multi-cluster is something, let's say you are in a particular location where the data needs to live near to the customer. So you might need a cluster in that region. And then you have another with the same application, you have, or with the other application, you have different data that needs to live with in a different geographical location. So you need different clusters for the different applications that where the data needs to live, or you need to serve the traffic closer to the customer. So you want multi-cluster kind of scenario over there where you can serve the traffic from closer to the customer location. Then obviously reliability is a very big thing. So data centers fail, like data centers can fail and they do fail. There are a lot of data center outages happened in the past, they happen today, and they will happen tomorrow as well. Maybe due to natural disasters, maybe due to fire, maybe due to a number of reasons which are there. So when you talk about reliability, you are bound to give your customers a good SLOs, SLAs, SLIs, all those metrics. And for that, you need to have a resilient cluster solution that you have built for your application. And with this, you have different options. Yes, one is multi-cloud. You can go multi-cloud. You can go multi-region because every cloud provider eventually will have a few regions with them, and you can go multi-region. You can have multiple apps, or you can have different applications per cluster, which you want to maintain. So with this is one of the reason. You might want to isolate your different environments, so you might need multi-cluster for that. You might need the same kind of application but with different set of parameters, with different set of configurations for each of your clusters. So you need devs, test, stage, prod, whatever environments that you need, and you need multiple regions for that. You might need them for performance isolation, for cost optimizations. You might prefer some region that has less cost over some region that has low cost, and for certain aspects of cost you might want to have different clusters in different regions. Then also you might want to have your highly sensitive data apps in one particular cluster and remaining apps in other clusters. So you might want multi-cluster for that. Upgrades is something which is always interesting and never straightforward. So you might want a different kind of upgrade scenario where you have one cluster and you spin up a new cluster, you move all the data over there, and then you just destroy this particular cluster with all the changes. I mean, the process should be seamless, but it's not that simple. So you might need for in avoid in place upgrades. So there are different efforts that have been made for years. So it's not something very new. The problem have existed, like most of the customers, and maybe Neil can touch more on that. Most of the customers that we talk to, they do need multi clusters. 80% of the reasons that I've mentioned before, and then other customized use cases. And then there have been efforts within the community where people have built solutions. So one of the first solutions that was developed was the federation, the KubeFed project, which is now archived. Like actually KubeFed V1, then V2, and then it got archived in, I think, April, somewhere around in 2023, last year. So it was basically so you have a main cluster, everything is getting federated, like all the Kubernetes APIs can be federated across to all the clusters. So every API is federated. Yes, it is Kubernetes native. Okay, it solves some of the challenges, but it introduces new set of challenges like single point of failure, issues like RBAC. How do you manage multi-clusters across different regions? All these complexities comes in, and then you have more resources that you have to pay for, you have more clusters that you have to manage. So all these things come in. So there is lack of management over there, single point of failure over there, and there is no need for having all the APIs. And that actually happened in 2.0, that some of the APIs were dropped. Like not all the APIs were federated. There were limited set of APIs that were federated, for example pods and stuff. They do not usually require to be having a federation on top of that. So then jointly, there is a SIG, special interest group within the Kubernetes ecosystem called multi-cluster group. These are the 3 points just taken from the GitHub repository, like expose workloads from multiple clusters to each other, share cluster metadata and its place relative to each other, and break down the walls between the cluster. That simply means that you should be able to communicate between the services, whether it's east-west traffic, or you should be able to use something like API gateway or the newer versions of ingress controller that incorporates a gateway API. for the north southbound traffic. So all these things they are working on, and they're still working on. And then there is a next successor project. Like there are two projects in the CNCF ecosystem, which is one is open cluster management. This is a community driven project, basically focused on all the scenarios, on the multi-cluster multi-cloud kind of scenarios, that provide set of APIs for the, so you have your main cluster registrations, and you can distribute workloads, dynamically place the policies, and different stuff. It has some of the features, like you have cluster inventory. That means you have set of multiple clusters connected to the hub cluster, and that will be managed. You have work distribution. So those are the set of like work APIs that will enable the resources to be applied to the hub cluster. Content placement, dynamic placement of the content, and vendor neutral APIs. Another project in this ecosystem is Karmada. So Karmada is again open source project within the CNCF ecosystem, aimed to enable you to run, that enables you to run your cloud native applications across multiple Kubernetes clusters with no changes to your applications. So it has the concept of propagation, and then you also can apply policies on top of that, which I'll show you just in a second. So again, Kubernetes native, it is commonly referred as one of the successors of the KubeFed project. So they also have a guide on how to move from KubeFed to Karmada. So it's a high availability, failed recovery, service discovery, and stuff like that. And coming to next, so that's how it looks like. So you have multiple clusters, and you have one control plane cluster, that which you call as Karmada control plane. And then you have your members, or whatever you want to call it. So you have member clusters that you attach to the Karmada control plane. And then you create your resource. So you create standard Kubernetes resources, for example, deployment services and stuff. And the placement happens when you create the propagation policies. So you create the propagation policies to tell how and where and how you want to deploy these workloads, and how these should be placed. And then you have an override policy. Override policy is pretty simple. Like let's say you have decided already where it is going, and then you have an override policy that overrides some of the changes that are required for your dev, stage, prod, and whatever clusters that is. So pretty simple. What we have done here is, I have already provisioned 3 Civo Kubernetes clusters: cluster A, cluster B, cluster C. Cluster A is acting as the Karmada control plane. So what we'll do is very simple: create a simple deployment, create a propagation policy, and we'll hope that it deploys to the member clusters as per the propagation policy. And then we'll create a client on one of the clusters, and then try to communicate with the server. So that's what we are trying to do. And this is the propagation. So this is the deployment. So regular deployment that happens, and this is the propagation policy. So you select the resources that you are selecting a deployment with the name, service with the name, and then you specify the placement. So you specify the placement that we want it to be placed on the clusters named cluster B and cluster C, and the scheduling type. So this particular stuff is weighted scheduling. That means one replica will be placed on one cluster, and another replica will be placed on the next cluster. So for example, if I do replica 1, it will only be placed on cluster A, and the cluster B will have the 0 out of 0 in the deployment. And when I increase the number of replicas, it will again go on cluster C rather than cluster B. So that's the kind of weighted thing that it goes to. So let me share, stop this and share the terminal, and hope that the demo works. So kubectl, yeah, we already have the nodes. And what we'll do is So this is the cluster A, and cluster A, if you remember the graph that I showed you or the diagram, cluster A is the Karmada control plane. So we have $K, what was that? KMD. Yeah, I just had some weird name, KMD get cluster. So we can get the clusters which are connected to this, which are cluster B and cluster C. Now what we are going to do is we'll apply the $KMD apply -f server. So what this does is it creates a deployment, but it won't, I mean, do anything because we don't have any propagation for that. So if you see, 0 out of 2 is ready, 0 out of 2 is available. So what we do now next is we apply the propagation policy to that I showed you. So propagation 1, the same one that was there. So we'll just do apply -f propagation 1. Now it should deploy. I mean, it should start deploying at least. Yep, both are ready. And then we'll do the client on cluster C. So cat client. So you can see a simple curl which is there. So we'll do a $KMD apply -f. No changes in the sorry for that. No changes in the regular deployment that we create. Client. So that's deployed. Propagation 2, if you see, we want our deployment, the curl one, to be going to cluster C. That's what we have defined in the propagation. So AMD apply propagation 2. So this should create a pod in the cluster C. And you can see 7 seconds ago, we have a pod that has been created in cluster C, and everything that we did was with the control plane, Karmada control plane cluster. So we go inside, we try to do a curl on the, not the right, yeah, the pi one. So we'll just change the pod name.
The contrast between this way and the Portainer way is going to be quite noticeable.
Yeah, so that's the reason, right? We'll be switching gears. And I have shown how, like, it's not simple. So it's not something which is simple. Yes, it works. There is also the concept of what is that? Service import and service export, which are part of SIG multi-cluster. That basically service export is a CRD used to specify the Kubernetes services that you want to export within the cluster. It came out after Kubernetes, I think 1.2x version, something like that, 1.21, 1.22, something like that. But yeah, again, in the multi-cluster ecosystem, how well you can, because networking is hard, and how easy you can make the networking using this. And Karmada do support service discovery using service import and service export. So going back to the slides, let me just do the last bit, and then I'll hand over to Neil. So there are still problems. Multi-cluster is hard from a lot of angles. Networking is hard, and they are still trying to solve it. Single point of failure still exists. A single view is also kind of not very good with the existing stuff that I've shown you in the multi-cluster ecosystem, especially with all both the projects that I discussed today. Policy point of view, where you can have deep policies for each of the clusters for each of the users, and also how each of the users, like it can be abstracted for each of the users, how they can log in, what is the RBAC for each of the clusters, how you can deploy apps seamlessly to the fleet of clusters. So there are a lot of things, a lot of moving pieces in the multi-cluster ecosystem. But I hope with this, you just got the gist of where we are with the multi-cluster state. There is a SIG multi-cluster doing a bunch of things, couple of projects. And now I would like to hand over to Neil to see if whatever we discussed today, can he simplify some of the things in the multi-cluster ecosystem with Portainer.
Okay, thanks, Siam. So I'm going to do things a bit differently. I'm going to talk a little bit and then maybe flick through a few screens in Portainer to show you what we can do. If I try and show you everything we can do, it'll go on forever. So I'll just talk a little bit and then flick through some things. And if we get time, I'll deploy some stuff and see how we go. So multi-clusters are really interesting, right? So you can, there are a number of approaches as you touched there for how you architect your cluster environment. A small number of very large clusters or a large number of smaller clusters. And each have their pros and cons. If you have very large workloads and you want to get very dynamic horizontal scaling, then obviously a cluster with more nodes is going to be beneficial. But a cluster is also a failure domain. And clusters fail. Anyone who thinks that clusters don't fail is kidding themselves. Clusters fail. Just before this, we were having a problem with the cluster controller manager. So clusters fail. And so often it may be wiser to actually have your application distributed across clusters so that you have no single point of failure in regards to a cluster itself. Again, clusters are supposed to be high availability and everything else, but occasionally things happen. But one of the things that we at least see is customers often prefer a smaller number of large clusters for no other reason than multi-cluster management is difficult. And not necessarily for the reasons that you just raised. I mean, of course, the CNCF tools that you just showed there and the complexity of networking, yep, that's one element. But even more rudimentary are things like authentication and access. And so if you have a Kubernetes cluster, you're going to want to provide your developers or your operators access to that cluster. So you'll need to give them a user account. You're going to have to configure RBAC roles for them, so to ensure they're safe and secure. If you're doing things statically and you're manually creating roles and manually creating users, as people cycle through the business, their roles change, they come and go. You need to manually update them in the cluster and then across multiple clusters. So you don't normally do that. So then you'd be installing some OAuth controller and trying to automate things that way. And really, it just starts getting too hard. And you can see why a lot of people are like, I'm just going to have a single big cluster rather than mitigate my risk and have a large number of small clusters. And so that's kind of the first thing that we're trying to tackle. It's like, well, okay, so if you have 5, 10, 20, 50, 100 clusters, how can you have a cohesive experience, user experience across them all? How can you quickly grant access to users to these clusters dynamically when they log in, log out, based on upstream authentication repositories? And then once you do that, how do you provide access through kubectl on a dev's machine or VS Code with the VS Code Kubernetes extension? How do you do that? You now have to be shipping kubeconfig files around. And it also means that on all of your clusters everywhere, you have to be exposing the Kubernetes API externally. Devs might want to work from the beach in Bali sometimes, as opposed to their home office or the work location. So you then have to be able to make sure that that kubeconfig file has the ability to connect to these clusters so you can manage them. So now you're like, okay, well, now we need some software to take care of secure tunneling, so Cloudflare tunnels or something else. So you've now got, not only do you have your Kubernetes environment to manage, you now have to have an authentication controller or mechanism. You have to have a way to configure RBAC. You have to have a way to provide secure tunneling. Well, the next thing you want to do is like, well, hang on a second. I want a way to be able to take my applications and deploy my applications across multiple clusters. Maybe you have a standard set of applications that you want to deploy. So now you're looking at some kind of GitOps solution and some central management GitOps solution. So you're going to deploy Argo CD or something somewhere, and then you're going to have agents in all the clusters. And now now you need to go and configure the pipelines to push those out to all these clusters. And really, the number of tools that you're having to bring into your environment to start to manage multiple clusters just complexity starts to escalate. So there's really, you can truly understand why a lot of people say, you know what, multiple clusters is just too hard. I'm just going to have a big cluster. You can really start to see it, right? It's just easier to have one cluster, one big cluster, than multiple smaller, because you're starting to just throw more and more tools at it to try and solve the multi-cluster management problem. Now, yes, I understand that you have service meshes and all these other cool tools to handle cross-cluster communications. I'm not even going there. That's up another level of complexity, even higher. I'm talking even getting the fundamentals right, the foundations right. And so that's a real challenge. How do you do this? And this is one of the things at Portainer that we're really trying to work on is, well, how do we actually do this? How do we have a single control plane or a single control access point or control point where you can actually provide users access to clusters? That can be an API proxy through to all the environments, and how can you deploy applications in one place? So that's kind of our challenge there is how do we do this? And that's one of the other things as well is visibility. You want to be able to log in somewhere, some dashboard. A lot of people don't like dashboards. They talk ill of dashboards, but being able to log in and seeing a dashboard of all your environments and being able to very quickly, go through those dashboards and say, well, what's going on? Are things up? Are things not up? Being able to do that in a central way is actually really handy. So, and these are the things that we're trying to address with Portainer. So I'm just going to quickly share something. Share screen. Now, hopefully things go okay. For whatever reason, I was getting some weird cluster controller managers restarting in the clusters. So if things fail, need to figure that out. So here is a copy of Portainer running. For those who don't know, Portainer is an open core product. So we have an open source edition and we have a business edition. The open source edition lets you manage Kubernetes clusters quite nicely. But the business edition is where you start to get into a lot of the features that I'm talking about here. We do have a 3 nodes free. So for people who want to have a little play, you can spin up 3 single node clusters across 3 Civo regions if you so desire, and you can start to experiment and see how this stuff works. But here I have 3 clusters, one in the New York region, one in London, one in Frankfurt. As you can see, all bar 1 is the latest version. I don't know why I didn't. I don't think I chose an older version, but clearly I did. So we've got 3 different clusters, and from here, instantaneously, you can see the 3 environments are up. So right now, you can see we're here. The heart beating says that the environments are up, and they're talking back to Portainer in this particular configuration. To grant access to these environments, there's a couple of ways of doing it. You can come into environments, and we can create groups of environments. So I can say I want to create a group for my Kubernetes environments, and you can put all your clusters into there. Or you can actually say on a per environment basis, I want to grant access to this, right? And so, but before that, going back a step even further, Portainer itself is able to be configured with user accounts, and this acts as your source of truth for your users. And going back even further, if you want to do that, you can actually say, I want Portainer to get my users from an external authentication source. So you can say, actually, Portainer, you don't need to worry about user management. I want to connect to my corporate directories or my OAuth corporate directories to grab my users. I want to be able to provision users automatically when they log in correctly. I want to be able to create them inside Portainer automatically, shadow users. And I want to be able to synchronize from the upstream provider any group memberships that they have. So if they're a member of a group, we will grab that group definition and their group memberships, and we will look to see whether there are corresponding teams in Portainer with the same name as groups, and if there are, we'll put users in those teams. So Portainer can sit here and can basically authenticate users from an upstream repository. And then once you have users in Portainer, and I've not done that for this because it's just simpler to rock through this thing quite quickly. We have users defined in Portainer, but just pretend they come from an upstream repository. You can now start to assign access to them. So you can say, well, actually, I want two teams, dev and ops, and I want users to be member of dev team. So, you know, the user Sivo is a member of the dev team, and in ops, the users Sivo2 and Sivo3 are a member of the ops team. So we've got users from an upstream repository. We have teams, also known as groups, but we have users and teams. And now we can start to grant access. So I can come and say, okay, for New York City over here, the cluster in New York, I want to manage access. And I want to give this particular team or this particular user access to this cluster. And I want them to have this particular role. Now, what we do here is we have predefined 5 RBAC roles. Now, the reason we've done this is because RBAC in Kubernetes is fraught with risk if you don't truly understand it. The way that the RBAC hierarchy works, a lot of people think that you have a positive, and then a negative can override the positive. Whereas that's not the way RBAC works. The RBAC is incremental. You grant progressive access to environments as you progress. And a lot of people get this wrong. They don't fully understand it. And you can end up with an RBAC role and role binding or role that does not secure the cluster in a way that you thought or the way that you intended. So what we have done is created these 5 roles, and these roles are managed by us. They are propagated into the Kubernetes environment. So we create the role in the environment, and we create the role binding for the user against this particular RBAC. So if I say this particular user or users in the dev are a standard user, and I can go and create my access, I will go and create the users inside the cluster. Again, let's make sure this one is okay. We'll go and create the 2 user accounts. So there are 2 users in dev account. We go and create 2 user accounts in the cluster, shadow accounts, and we go and assign those users the RBAC role of standard user inside that cluster. If a user was to log in on that one, now that was the dev team, I think. I should have paid more attention to myself there. That was the dev team, and so the dev team is the user Sivo. So if I log out and log in as the user Sivo, you see they've got access just to the New York City cluster. And if I come into that cluster, you'll see that I have access to just the default namespace. There are no other namespaces available for me. And again, if I log out and log back in as the admin, I can actually come and say, well, now I want this user to have access to other environments. And so I can come back in the same thing and say, actually, I want to give the same group of people access to London, but I want to give them an environment administrator role. And this environment administrator role is basically a higher privilege. I probably should have described the roles before, but I'll do it now. So we have 3 cluster scoped roles and 2 namespace scoped roles. And so what we have, I'll just click into here so you can see. When you grant somebody the environment administrator role, they have complete access to the cluster. No other clusters, just the cluster that's been granted. When we have the operator role, they can engage or interact with resources that are already deployed in all namespaces in the cluster, but they cannot create new, they cannot delete, so they can start and stop and troubleshoot. We have the help desk, which is a read-only view, so they can't actually make any changes to a running system, but they can see what's happening across all namespaces, again, just for a cluster that they've been assigned. Then you come to a standard user, and a standard user has the ability to access all resources within assigned namespaces within assigned clusters, and a read-only user has read-only access to resources in a namespace in a cluster. So they're the roles. And so we can go through, and it's pretty easy for us to grant access to users. And again, if I log out and log back in as the CEVO user, we should now have the two. And if I come into London, then we will have access to more namespaces because I granted myself the admin role. So you can see here, I've got access to two namespaces because I granted myself, or granted that team, I should say, the admin, cluster admin role. And so they can now see everything in this. They can see all applications. They can see everything in that cluster. So I go all namespaces, you can see whatever's running in there. And so we make it very, very simple for you to actually take care of user authentication and user and RBAC roles into clusters, and that's pretty useful. At the same time, we give you the ability within a cluster to configure things like OPA gatekeeper policies. We can come into a cluster here in New York again. We can come into the cluster. We can see information about the cluster. So you can see this is a 3-node cluster. We can see the resources that are used. We can come into security constraints, and I can turn on the constraints, and I can flick on some switches here for some policies. And basically what we're doing behind the scenes is deploying OPA gatekeeper and applying an OPA gatekeeper policy into the cluster for you on your behalf. So you don't need to worry about that. And so again, from a central location, we make it nice and easy for you to go and turn on a bunch of advanced security into the clusters. So that's pretty useful from a central observability standpoint. The other interesting thing is, you see there's a little button up here, kubeconfig. If I click this, it'll actually generate me a kubeconfig file. And inside that kubeconfig file, if I look at it, you'll see the server for all of the clusters is actually the same IP address. And that's because Portainer is acting as a API proxy. So if I was to import this on my machine, and I would be able to see all three of those contexts, and I'd be able to engage with each of the clusters from my Kubernetes local, my kubectl local deployment, or whatever local tooling you have, through Portainer as a secure proxy. So you don't actually need to expose your Kubernetes APIs externally at all. Portainer will tunnel those through the Portainer server and then through our secure agent connectivity to the backend clusters. So that gives you a really nice central way of managing this, all from one location. So you start to get some real useful centralized management. In this particular environment, I have elected to deploy the Portainer Edge agent. Now, we have a couple of ways of managing environments. We have our regular agent, and then we have our Edge agent. And the difference between these two is whether you're managing them over an insecure network or whether you're managing them over a secure network. And because in this environment here, these clusters are just across public internet into the CEVO cloud, and I haven't got any firewalls or VPNs between me, we are using the Edge agent here. And the Edge agent runs in the cluster, communicates back to the Portainer instance to receive all of its command instructions. And if you didn't notice, when I'm clicking on a cluster here, you see here live connect, live connect, live connect. When I click a cluster, it actually takes, well, that one wasn't, because I was obviously still managing it. It takes a few seconds because we actually raise a flag, and when the remote agent is polling back to Portainer, it sees a little notification that says, hey, there are management tasks for you. It opens a reverse tunnel back to Portainer, and we can now manage this cluster across a secure tunnel without having any direct inbound access to that remote environment. So that's quite useful. But as a positive byproduct of using the Edge agent, you get to see these edge compute features. Now, most people who use Portainer may never have seen these edge compute features, and that's because you have to first turn them on. So under settings, edge compute, you can turn on the edge compute features, and then you get a whole new product within a product, fundamentally. And this is a way of bulk managing or managing multiple environments at the same time from the one central location. So here, for example, we can say, I want to create a group of devices, France, London, and New York. And we're going to call these things CEVO. And these are a group of remote clusters. Static is one way. You can also do these dynamically using labels and tags and other things, but we can create a group of devices here. And then using this group, we can actually come in and say, well, actually, I'm going to deploy an edge stack, and I want to be an edge stack. I want to deploy it to the CEVO group. We will recognize that it's a Kubernetes environment. And I can say, do something like Node-RED, and I can get a Node-RED manifest here and paste it in. Obviously, in the real world, you'll use a repo and you'll use GitOps to manage all your repos, but for the sake of simplicity, we won't do that. And so you come through and say, well, here is my manifest, and I'm going to go deploy it on all nodes in the cluster. So I go deploy, and this will simply go and deploy. Now, I should, in theory, be able to come back to my CEVO portal, go to networking load balancers. In due course, this takes a little while to occur. And eventually, that manifest that I deployed is going to deploy a Node-RED environment, and it's going to ask for Kubernetes to spin up a load balancer. And in theory, this should show up in here very soon, and you'll see a load balancer. So there you go. 3 of 3 deployments have received the instructions, and it's running. If I come back into, say, New York City, and I go to my applications, you should see a namespace called Node-RED, and inside there, it's still waiting. So obviously, this is going to be waiting for the persistence layer to come up, probably. So yeah, load balancer. So we're still waiting for the volume to come online, but basically, this will eventually come online, and you will be able to manage it or actually use the application locally. But we did this using edge stacks, and we're able to deploy this application to all clusters from the one location. And again, if you didn't use Portainer for this, you'd have to be going and deploying something like Argo CD centrally. You'd have to deploy the Argo agent in all your clusters, and then you'd have to come and configure yourself an Argo pipeline. We can do the same thing with Portainer automatically, Kubernetes, repo, GitOps updates, set your reconciliation loop options, set whatever other options you want, and go and deploy your application directly into multiple clusters from the one location. So it makes it really, really simple to manage devices or manage clusters en masse, or applications en masse across your clusters. Makes it really easy to manage user authentication and access. Makes it really, really easy to manage centralized access from whatever dev tools you're using, VS Code, Kubernetes extension, kubectl on your machine. Just makes it really, really nice and simple to get access to it. So that's kind of what I wanted to show at a really, really high level. Hopefully this load balancer has finished ensuing, or the volume has as well. Let's have a look. Not yet. But anyway, that is the way that we manage this stuff all from Portainer in a really central way. So Simon, were there any questions while I went on that little rant there?
Yeah. So you were checking which region did you create the load balancer and which region we are checking in, if you can see in the CEVO dashboard.
Oh, so because I asked to deploy the stack to the group, in fact, all three of the clusters have received the instruction. Okay. So all 3 of these will actually eventually deploy. So I'm in London right now. I can switch to New York as an example, and eventually this thing will spin up a volume. There we go. So this is already the 10 gig volume, and if I go to networking, load balancers, You will see a load balancer come up. There we go. So there's the Node-RED load balancer. So again, if I come back here and come to my applications, refresh the page. Okay, it's still coming up. There you go, access. So you'll see there we already have, well, Node-RED will come up and be able to access it. Still waiting here, obviously waiting for something for the storage, looks like. Something, anyway. But yes, so the load balancers will stand up across all the clusters. The other cool thing is, even once this is done, I can actually come through here and remove them. And of course, as we do that, when I come back to the load balancers, Portainer is not just deploying, we're also going to clean up. So the load balancer will actually go away at the same time. So when I come in, it'll eventually tell Kubernetes, hey, clean up, and it'll go and remove the load balancer. And depending on the storage class policy, it'll also delete the volume at the same time.
And also, when you showed the GitOps thing, so you have the stack of clusters to where you can deploy a single application, right?
Yeah, so edge stacks, you basically deploy, you set up a GitOps pipeline and you're deploying an application to a group. So you can have multiple groups. So you say to a group, and then it'll deploy the exact same manifest and configurations to all clusters in that group. So if you've got 10 clusters or 100 clusters, they'll go and deploy it to there. There's actually nothing stopping you coming in and saying, actually, on this particular cluster, New York City cluster, I want to deploy an application manually from a Git repo or from a Helm chart, and doing things, one by one on a per cluster basis. Also, nothing stopping you saying, I have an edge group called Civo, but I also want an edge group called New York City, and I'm just going to have the New York cluster in it. And say, I want an edge stack that way. So you can actually come and create your groups and then deploy your applications to your groups, either all nodes or all clusters, some clusters, however suits your application.
Yeah, and otherwise, for the audience, this would have been possible if you have Argo CD installed or any of the tooling, and then you connect all the clusters to that Argo CD, and then you create application set. So you have an application set controller, you create the application set, and then it kind of deploys. So, and you can see how it is done in Portainer. Like, that's cool.
Yeah, it's so quick. I mean, most people's experience with Argo CD is they deploy a copy of Argo CD per cluster, and that would be a nightmare to manage at scale. And the lesser known or the less common deployment is a single Argo CD deployment in a management cluster somewhere, and then the Argo CD agents running in all the clusters. That's not as common. Most people just have a copy instance per cluster. We do the same thing here. Portainer acts as the GitOps controller, and basically make sure that what's running in the remote clusters matches what's stored in Git. And if there are changes, like, again, I'll just talk through the page here. If I turn on GitOps updates, we have the ability to do things like force redeployment. So force redeployment basically says, even if an administrator has made a change to a running configuration, override that configuration with whatever's in Git. So this is a force reconcile. You might want to turn that off, because if there's ever a failure situation, you may want the administrators of the clusters to be able to get in, roll up their sleeves and solve the problem, and then worry about the source of truth in Git later. But you may not. You may say absolutely not. Even if there's a failure situation, you need to find and fix the problem in Git, and then let GitOps reconcile and resolve the problem in the cluster. So that's an option. And repo image is something we added. Everyone is told never to use the tag latest. Everybody uses the tag latest for images. Let's just be honest, we do. And so repo image says, just always repull the image regardless. So every single reconciliation loop, always pull the image and redeploy just in case there's a new version. Don't just assume that because the tag hasn't changed that there's no need to apply a difference. Always repull the image and redeploy anyway. So it's bad practice and an anti-pattern, but trust me, many people do it.
Well, thank you so much, Siam and Neil. Really appreciate you digging through this. I actually had a question, but you guys summarized it perfectly. Just asking how easy is all of this without Pertainer? And I think the short answer is it's not. So really appreciate you digging into that. We do have quite a few questions. I know we only have about 8 minutes before we wrap up. So the questions are going to appear down at the screen. Siam, I'm going to let you read those out, and then I'm going to let the two of you kind of take over. We'll probably be able to get through maybe 2 or 3 of these, and then we will wrap things up as soon as we're done. But again, thank you both so much, and I will hop off.
Yep. So how does the centralized multi-cluster management integrate with existing legacy systems and infrastructure within an organization? Neil, your thoughts?
So if you are having multiple clusters, from a networking perspective, things get complicated as was discussed there. If you want your applications to be able to communicate across some internal overlay type networking, then you are going to need a service mesh or some mechanism to actually have all of the clusters share a common virtualized networking layer. If you don't, then all of your applications will be exposed externally using load balancers if you're lucky, if not, node ports. And so then any existing infrastructure applications have to know to talk to that application using the node port and not common ports that you might see. So obviously when you start mixing new modern microservice architectures with legacy systems and infrastructure, already you better hope that you've got some kind of load balancer to take care of port abstractions. But when you have multiple clusters, things get a bit trickier. So
Cool. Could you discuss the strategies for disaster recovery and data redundancy in the centralized multi-cluster environment?
Well, disaster recovery is an interesting one. So if you're doing it right, then disaster recovery should just be a matter of spin up a new cluster, reapply any kind of GitOps policies, and off you go. And that's if you're doing it right. If you are manually deploying things and you've got a lot of persistence to worry about, and then you have to try and obviously rebuild or create a new cluster and manually replay what you're doing. And to be fair, that's one of the big benefits of GitOps is the actual configuration is stored externally. So from a disaster recovery point of view, if just rely on external sources of truth for your manifests. Make sure that your cluster provider, Civo, doesn't use a storage volume class that auto deletes. Make sure that you've got one that will retain. So if the cluster goes away, you can spin up a new cluster and you can remap to existing volumes. So I'll do that one there. And data redundancy. Really, the best way to do that, at least in my opinion, is in application. So have the application having multiple replicas. Most of the database providers will let you have multiple replicas, so you can actually have multiple masters, and you can write multiple copies of your database across clusters. So you can have one master on one cluster with one persistent volume, another master on another cluster, another persistent volume, and you can actually have the databases replicating and store and writing their data. That's how I would do it. I'm never a fan of relying purely on infrastructure. I like to let the application layer do what it does best, which is get its data replicated across multiple locations.
And just that's where, agree on that. And that's where HA, every kind of open source tool have their HA deployment because of the same reason. Like you don't want single point of failure. So even in Karmada, if you see there is a HA deployment of Karmada, so that even Karmada is not a single point of failure, and you have some sort of data redundancy or replicas over there that can fail over across nodes. If one node shut down, there is something other that can serve the traffic. So all these things should definitely be taken care. on a point of disaster recovery, I think you should also like having disaster recovery is fine, but there should be a practice to kind of test disaster recovery as well, because if you directly test at the time of the disaster occurring, it might be a problem because you think stuff will work, eventually it might not work. So I think it's a good practice to kind of do a healthy checks, half yearly or quarterly of your disaster recovery setups.
Actually, one of the things I recommend, and I'm a fan of never actually upgrading a cluster. I always like to build a new cluster and basically get my applications running, because that means every time you want to do a version upgrade, you've just tested your DR strategy perfectly. So you're able to spin up a new cluster and get all your pipelines and your apps running again, and update any load balancers and or redirection rules. You've just proven DR. So me personally, I never upgrade a cluster. I always build a new, migrate across, and that way you 100% know categorically something goes wrong, you can get up and running again quickly.
Yep. And how, so I think we'll take this last one. How do you envision the future of multi-cluster operations evolving?
It's got to get easier. We're trying to make it easier. There's still many things we can do. We want to be able to say, okay, well, here are some security policies, propagate them everywhere. Here's a bunch of other policies and controls, propagate them everywhere. And so it has to get easier. I think that we will definitely see more clusters than less in the future. Multi-region, multi-cloud provider, some on-prem, some in the cloud. The cost differential for a Kubernetes cluster is so dramatic between cloud providers. There's absolutely no reason that you need to have your dev environment on the most expensive cloud provider on the planet. Move it around. And so I think absolutely, as we get more cost conscious, and there are people looking to move back from cloud, back to on-prem, I think that's actually a little bit rash. And maybe, just maybe, you should move from some of the very expensive providers to some of the less expensive providers for workloads that don't necessarily need the features and capability of the top tier providers. Now, why do that? Because it makes sense commercially to do so. But as you do that, you're now increasing your complexity. And so a lot of people are saying, well, if I can't go there, I'll go there. Again, because of operational complexity. So I think we will see multi-cluster operations become the absolute norm, and I think we'll find a lot of tooling and capability that make managing multi-clusters as easy as managing one cluster.
Yep, and agree to the simplicity point that and to the adoption point. So multi-cluster and multi-region, multi-cloud will be adopted more and more. We at CIVO promotes multi-cloud, multi-cluster strategy as well. And also the ease of operation. So like Portainer moving in the way forward of policies, having Kyverno and all these integrations in the future, making it easier to have security stuff along with management, along with deployment, all these things. And then eventually all the other toolings like Armada and stuff, they are easing out on the networking side of things, how that can be solved easily for easy spanning of your workloads across the clusters. So yeah, simplicity and making things easier is something multi-cluster, and multi-cluster SIG is also kind of moving forward.
The other thing, right? So Kubernetes at the edge is starting to get pickup. Now, you cannot avoid multi-cluster when you're talking about Kubernetes at the edge, because now you've got 100, 200, 300 edge locations. Each of those is a unique individual cluster. You can't avoid it. You simply can't. I mean, obviously there's KubeEdge and a few other projects that are trying to say, well, we actually have a single virtual cluster. So that's one approach. But when you're talking about lots of discrete Kubernetes environments at the edge, you're at multi-cluster. So you better have the tooling.
Yep, and you can check out K2D project for that by Portainer.
You can.
Amazing. Well, it looks like we are officially out of time. But again, I just wanted to thank you both, Neil and Siam. You've been wonderful having on today's webinar. If anybody has any questions for them, feel free to pass it over to the CIVO team, or you can check out portainer.io, and I'm sure Neil will be happy to chat with you further. So I'm going to go ahead and move you both off stage. Any last comments?
No, feel free to email me. I'm just neil@portainer.io. That's founder privilege. You can just have first name as your email address. So I am very receptive to emails.
Amazing.
Yep. And thank you so much for tuning in and listening to the multi-cluster stuff.
Perfect.
Thanks
Well,
for having me.
Thank you both. I'm going to move you backstage. We've got one quick announcement before we end the live stream. Here we go. So if you enjoyed this webinar, we have a number of webinars coming up, so please keep an eye out for those. We also have some amazing in-person events. We do a CIVO Navigate conference, both in North America and Europe every year. We also do local events as well. So these are one-day versions of our two-day flagship conference. Our next one is going to be April 16th in Tampa, Florida. We would love to see you there, especially if you're in the area. If you have any questions on this, feel free to scan this QR code. All the registration information, schedule, and contact details should be there, and we'd love to chat with you further. But again, thank you both, Neil and Siam. We really appreciate you both joining us today, and we hope to see everybody soon. Thank you.